Hello, everybody. This is a 10th lecture on atomic and molecular physics, specifically on hydrogen atom. It's about atom in external magnetic field. Now, we know that an electron, it moves around the nucleus in an atom. And when we consider an electron moving around the nucleus, it is equivalent to current carrying loop. So, when there is a current carrying loop, we know that there is a magnetic moment associated with that. So, analogous to that, whenever an electron moving around the nucleus, there is a magnetic moment associated with that, and it is called as mu L. L is, we know that it is orbital quantum number, and as this magnetic moment it is there because of the orbital motion of the electron in the orbit, it is called as orbital magnetic moment. Now, when such an atom it is placed in a magnetic field, there is an external torque which acts on the atom, and that torque is given by the cross product of magnetic moment and magnetic field. Now we know that by the definition of cross product, suppose vector C is equals to A cross B. In that case, this vector C, it is perpendicular to A, this vector C is perpendicular to B, this vector C is also perpendicular to the plane containing A and B. So similar to that here, as torque is defined as the cross product of mu L and B, this torque, it will be perpendicular to mu L, it will be perpendicular to B, it will be perpendicular to the plane containing mu L and B. Now, this external torque acts on the electron, tending to align the magnetic moment parallel to the field, parallel to the direction of the magnetic field. And this torque is perpendicular to mu L and hence to L as well. Why we are saying that this torque is perpendicular to magnetic moment as well as to L? Because magnetic moment and angular momentum, they have the same direction of magnetic moment and angular momentum, it is same. So when I'm saying this torque is perpendicular to mu L, that is magnetic moment, obviously this torque will be perpendicular to angular momentum as well. Now, we know that whenever an external torque acts perpendicular to the angular momentum, a precession of angular momentum vector L takes place about the field direction, with the angle between L and the field direction remaining constant. So, there is a precession of angular momentum vector L, as we discussed in the last lecture also. Hence, the tip of the vector, here it will be constant, and the tip of the vector L, it will precess about the direction of vector B, because B we are going to take along Z direction. Suppose this is vector B along the Z direction, and there is a vector L, so it will precess about this B, about this B. Now, due to this precession, there is a change in the energy of the atom, and the atom acquires an additional energy. The additional energy acquired by the atom because of the external magnetic field, it is given by the formula E magnetic, it is equals to minus mu L dot B. Now, by definition of the dot product, we know that A dot B is equals to AB cos theta. So I can write here minus mu L B cos theta. Now, we know that mu L, it is EL upon twice m. This we derived in the earlier lecture. So for mu L, I can write EL upon twice m. And this is B here, and L cos theta. Now we know that L cos theta, it is equals to LZ. So for L cos theta, I will substitute LZ. So I will get E magnetic equals to EB upon twice m into LZ. And we know that when we studied the LZ operator, that time we calculated the value of LZ. LZ is given by ml h cross. So I substituted the value of LZ. So I'm getting E h cross twice m up into B ml. So E magnetic, it is E h cross upon 2m into B ml. So what are Zeeman levels, or what are magnetic levels? Now here we have seen that ml, we know that magnetic quantum number ml, it can take up 2l plus 1 values for a given L. So here the L level, it will split up into 2l plus 1 sub levels in the presence of an external magnetic field. What happens? We have a L level, and corresponding to each value of L, there are 2L plus 1 values which ml can take. So what is happening here, L level hai, that L level it will split up into 2L plus 1 levels in the presence of an external magnetic field. So these 2L plus 1 sublevels which are formed because of the splitting of L level in the presence of magnetic field, these are called as Zeeman levels or magnetic levels. Now here there is one more question which arises, why ml? We know that we have n, that is principal quantum number, L, that is orbital angular momentum quantum number, and then ml, that is magnetic quantum number. So why this ml, it is called as magnetic quantum number? So the answer is here itself. Since the number of allowed values of ml for a given L gives the number of magnetic levels. For a given L, we have twice L plus 1 values of ml. We also have twice L plus 1 values of magnetic levels in the presence of an extra magnetic field. That is the reason why ml is called as magnetic quantum number. Now this vector L, it can have 2L plus 1 orientations because we will have cos theta values also. So this vector L can have twice L plus 1 orientations with respect to an external field for a given L. Now we will consider we will solve certain problems related to SPD states. Then this splitting of magnetic levels from L state to twice L plus 1 values, that will become more clear to you. So now we will consider an hydrogen atom in S state. Okay? So we know that when an hydrogen atom it is in S state, for S state L is equals to 0. L is equals to 0 और E magnetic की value L 0 है तो obviously ML भी 0 हो जाएगा, and we know that E magnetic it is given by EH cross upon twice M into B ML. ML 0 है तो ये value भी 0 हो जाएगी, so E magnetic will also be 0. That means energy of the atom is not changed in the presence of magnetic field in case of S state. Now let us take the example of P state. Suppose P state में है. So we know that for P state L is equals to 1. L is equals to 1 और ML की values क्या होती है? For -1 to +1. That means 1, 0, -1. So E magnetic भी क्या हो जाएगा? E magnetic ML में 1 सब्स्टिट्यूट करूंगी इस फॉर्मूले में. So it will become EH cross upon twice M into B for ML is equals to 1. ये 0 हो जाएगा. For ML is equals to 0. अगर मैं इसमें 0 सब्स्टिट्यूट करूंगी, E magnetic will be 0. And then it will become minus EH cross upon twice M into B for ML is equals to -1. So I can draw, see, for L is equals to 1, this L is equals to 1 level, it has split into 3 sub-levels. This is for ML is equals to 1, 0, -1, and corresponding energies minus EH cross upon twice M into B, 0 plus EH cross upon twice M into B. This is how we can draw. Now let us take one more example. Suppose the electron it is in D state. So if it is in D state, we know that L is equals to 2. L is equals to 2 है, ML can take value 2, 1, 0, -1, -2, right? Because ML can take values from -L to +L. And for this, obviously, we will have 5 values of ML. So L is equals to 2. It splits into 5 energy levels or 5 magnetic energy levels or Zeeman levels. So ML equals to 0, ML is equals to 1, ML is equals to 2, ML is equals to -1, ML is equals to -2. And we know that E magnetic, it is equals to EH cross upon twice M into B ML. तो मैं ML की value 2 substitute करूंगी, तो I will get this as 2 EH cross upon twice M into B. If I will substitute ML equals to 1, I will get EH cross upon twice M into B. For ML equals to 0, I will get 0. Here I will get minus EH cross upon twice M into B. Here I will get minus 2H EH cross upon twice M into B. what does this mean is, except S state में there is no change at energy of the atom is not changed in the presence of magnetic field. But if you take P state or D state, then in the presence of magnetic field, the energy level splits up. So the energy difference between any two consecutive magnetic levels, it is, so if you calculate the difference between these two levels or difference between these two levels, you will get EH cross upon twice M into B. So difference between any two consecutive levels, it is EH cross upon twice M into B. So that's all about atom in an external magnetic field. Thank you.